It's getting close to the end of the semester, in case you didn't notice. So it means you're getting the opportunity to work on the more fun projects. I thought it might be helpful if we kind of got you started on this attack project. Uh, I'm hoping this will save you a little bit of time in figuring out how to do it. So first of all, if you take a look at this, the first thing you have to do is download this PDF that has some stuff in it. Um, it will only work on the CS Lab machines, a particular subset of them. And you're welcome to work with other people, but you have to do your own thing. The one thing that's kind of nice about this is there's a scoreboard here which shows who's completed which pieces of the project. So let's go ahead and take a look at it. Again, you're going to try to type in, you can think of this as, this is a program that requires a username and a password. And you're going to try typing in crazy usernames and passwords to try to hack into the application. This is actually a typical attack scheme for hackers. So it will also help you to understand x86 instructions and stack frames. And I'm hoping that it will make kind of be the culmination of everything you've learned in the class so far. So first thing you're going to do is go to this website, which is going to let you put in your username and download a tar file. And then you're going to extract that. It's going to have this ctarget and rtarget programs that you can attack, and a hex to raw program that will let you figure out what characters to put in to make the application do something different than what it was intended to do. You cannot attack in other strange ways. You should just be able to use the return instruction to go to a different place, like this touch one function. And so anyway, here's the program. It's got this function called getBuff. And what you're going to do is it's going to call gets, which gets a string from the terminal. You want to type in something that will overflow this buffer and write over the return address so that the program goes to a different place than it was expecting. And so I think that's kind of the main set of stuff we wanted to go over. And so maybe just if you want to follow along with me, first of all, download the tar file, and then you should be able to go to so you should SCP your tar file over to one of the destination machines, and then do untar it. That tar file, and it should create this directory for you, something like target 131, which is what mine was. Okay, once you get into here, you should be able to run this program and start typing in a string, random string here. If you type in short ones, it should just say nothing happened. If you type in a longer one, it should go ahead and get a segmentation fault because you overflowed it in a way that it didn't work. And so what you want to do is put in the right set of stuff to make it call this particular function. So let's just take a look at this. Again, first you're going to want to run GDB. Oh, one other thing I did want to mention is that they mention here that you probably want to take a look at the book, particularly 3.10.3, which will talk about out-of-bounds memory references and buffer overflow. And this is a real good thing. It gives you some tips on using GDB and what the stack looks like. Again, here's the buffer, here's the return address, and I would go ahead and read through this. It will make it a lot easier for you to figure out what to do in the program. So let's go ahead, and here we are. We've got things running. We can say GDB, and let's start taking a look at this. So the first thing they told us was that we should expect that there's going to be this function called getBuff, and it's going to have the buffer declared in it. And so probably the first thing you want to do is you want to set a breakpoint at getBuff. And I can go ahead and run, and it should go ahead and stop there. And then I want to go ahead and look at stuff. So I probably want to try doing the traditional layout ASM and layout and for some reason it's got all unhappy with me. So let's run it again. And now we can see our registers and the assembly code. We can break in getBuff and run. And so here we are. Here's the first instruction in getBuff. It's going to decrement the stack pointer, and then it's going to call this getS string. And so what we would like to do is go ahead and take a look at what's going on now and figure out how to change things. So you might want to do an info frame, and that will tell you, here's your stack frame. I probably want a single step, so it goes ahead and decrements the stack pointer so that I can say, see what's going on. And now you'll notice that my local variables should be at this particular address. So I will go ahead and display that area. And so here's my local variables where it's going to start putting in, again, if I go back, here's this getBuff. Its local variables are going to be this thing, so it's going to be there. And then it's going to have the return address that it's going to go back to. And so let's just experiment with it a little bit, and so that we can see what's happening. And so maybe I want to set another breakpoint at the end of this. Here's getBuff, right? We called getS. So let's set a breakpoint right after it gets back from getS so we can take a look at things. And go ahead and do a continue. And now I'm going to type in my string, which could be something like a bunch of A's. I kind of know what those should look like. And now it should stop at the breakpoint. And now, by the way, if you do Control P, it will allow you to go to previous things you've typed in. Control N is the next one. So I can now display that again. And notice what it's done. Here are all those A's that I typed in. And so you can see how this is my local variable area. It started putting all of those in. Okay? And if you keep looking up here in the stack frame, you'll notice here is the return address. So if you take a look and at the other assembly instructions here, there's going to be this test function, and he is going to call getBuff. And notice the next instruction is going to be this 41A7E, which is the address that test is going to return to after he calls getBuff. So what you want to do is override this with the, we want to do touch 1, which is up here. So we want to replace it with this address. Okay? So let's go ahead and take a look at this. So how many of these characters do we have to put in? So it looks like it starts at 3.8, and we want to go all the way to 7.0, right? So if we do something like 3.870 minus 3.8, that's 38 hex of junk we need to put in, and then which is 56 bytes, and then we want to overwrite that address. Okay, so now let's go ahead and see how to do that. So if we wanted to, we could go ahead and open up another window here, and inside of that same place I'm going to go ahead and SSH to California again. I don't think I've got another one here someplace. What is that not working? Clementine, California. Okay, so if you take a look at this, so we've got this little program here called hex to raw. So the easiest thing to do is to create another file that will have the stuff you want to put in. I'm going to edit this file called foo, and I've just, on each line here is 10 bytes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10, 20, 30, 40, 50, 6 bytes. And then I want to put in this new address I want to go to, which is, let's see, here's touch 1. Touch 1 is at 4018A3. 4018A3. So I want to put that in, but remember I need to put it in little endians, so 004018A3. So I want to put it in there. And then I'm going to go ahead, and so what it should do is it'll throw all of this. That will go from here all the way to there. And then I wanted to put in the new return address 4018A3 instead of 401A7E. And then when it goes to do the return from this getBuff function, it will instead go to this touch 1.
Here's an answer from
Okay.
MathSysFin.com.
So let's go ahead, and the next thing we want to do is to run hex to raw and take the input from my this thing I've just done, redirect the output to bar, and it's just going to basically so now we can look at bar. I always like to use OD octal dump minus x on bar. And what it's going to have in it is, so here's all those dead beefs. And then it's going to have this 40A318 and then a 0A, which is a carriage return, which is what getS is looking for. So it's going to put all of this stuff into the buffer and then stop when it sees a 0A. Okay, so that's all now in this bar file. And so now what I can do is, let's go back into GDB, and I can say, okay, let's run this, start over from scratch, but redirect the input from bar, that file I just created. And so what will now happen is it'll start from the beginning. There's my breakpoint at the start of getBuff. Let's do a continue, which will go to the next breakpoint. And now let's take a look at things. Again, Control P gets me back to that thing that was displaying what's on the stack. Now you'll notice that this is all filled up with all those dead beefs, and except here at the address where I normally would be the return address to 401A7E, instead I've put in the one for touch 1, which is 4A18A3. Okay, this is so exciting. So isn't this just like a puzzle? I hope you guys are going to have a lot of fun with this. So now if I continue, it's going to actually try to return from getBuff, but instead of going back to test, it's going to go to touch 1. And so it will say, you called touch 1. This is a valid solution for level 1 with target ctarget. This was validated. Nice job. Aren't you excited? Well, maybe not all that excited. So hopefully work through this. If you need more help in getting started on this lab, let me know. It took me a while to figure out all these pieces, so hopefully this will save you a little time in getting started. And the next exploit that you're going to work will be phase 2. You're going to want to call touch 2. Then you're going to, now one thing I wanted to mention to you guys, notice the bulk of the points are in these first phases, right? So if you don't get to this last phase 5, it's not worth very many points. So don't burn yourself out and think you need to necessarily get all of them. But I'm telling you, you're going to have so much fun once you get started that you're going to want to do it. It's going to be a little more complex on these other level 2 attacks. You're going to actually have to create some code that you'll be calling. But I think that it's pretty clear in here what you need to do now that you've known how to get started. So jump in, have a lot of fun, and I hope that this is kind of the capstone to the whole class, where you actually get to use your knowledge of machine organization to actually perform a attack that is still very prevalent on the internet, because you can type in crazy passwords on any application. If the programmer's been careless, then you can go ahead and get access and have their web server do anything you want. So it's good to talk with you. One comment though, even though this is we're assigning you to attack this particular program, do not do this on random web servers out on the internet, because if they catch you, they'll lock you up and throw away the key. So you've been explicitly given authority to go ahead and access this one, but don't try to attack other machines. So let me know if you want more help on this lab, and otherwise I'm hoping you all be successful. Thanks.